Hi everyone, welcome back to our channel. So today we are going to solve this problem, finding out the open circuit parameters, where the open circuit parameters are Z11, Z12, Z21 as well as Z22 for the given T-type network. Okay, so if you want to understand about this polar form, you can watch the video on complex numbers in my channel, so you can get a complete clarity about the complex numbers addition as well as the division and multiplication. Now let us try to solve. Okay, so here when you take this network, let's try to solve it. Okay, so here whenever the entering current is I1. Okay, so whenever current is entering, this is positive, leaving is negative. Whenever the current is enters this port, this is I2, this is positive and negative. So we need to find out the current in this branch. So we are going to apply Kirchhoff's current law at the node. So what is Kirchhoff's current law? Entering currents is equal to leaving currents. What are the entering currents? I1 current is entering and I2 current is also leaving, entering, and Ix is leaving. So entering currents are I1 plus I2. The leaving current is Ix. This Ix value is now I1 plus I2. Now let's try to apply the KVL at input side and output side. So I'm going to redraw the network. So if you take it as an AC supply, also no issue, or an DC supply also is no issue. Directly take as this is V1 with a inductance in ohms, which is plus J40, with a capacitance, and once again with an inductance. This is J80 ohms. This is minus J160 ohms. So here the voltage is V2. So current is entering, this is I1, here I2, and current in this branch is I1 plus I2. So whenever it enters, this is positive terminal, negative terminal. Whenever the current is entering, this is positive terminal, negative terminal. So this will act as a positive terminal and negative terminal. So why you marked in AC, polarities will not be there. No, just write down the KVL. There you can understand better. Okay. Now let's try to write down the KVL equations. Apply Kirchhoff's voltage law at input port. So this port, we are going to apply the KVL. So whenever the current is leaving, what is the polarity of the voltage, which is plus V1, and current is flowing, what is the leaving polarity, minus I1 into J40, and the current is, what is the leaving polarity, minus I1 plus I2 into minus J160 is equal to 0. This is one equation. Second equation is, write down the side. Current is leaving. What is the leaving polarity? This is plus V2. This is plus V2, and the leaving polarity is minus I2 into J80. Next one, what is the leaving polarity? Minus I1 plus I2 into minus J160 is equal to 0. Let us shift all these negative terms to the right hand side. So V1 is equal to I1 J40 plus I1 plus I2 into minus J160. V2 is equal to I2 J80 plus I1 plus I2 into minus J160. Okay. So here V1 is equal to I1 J40 minus J160 I1 minus J160 I2. V2 is equal to minus J160 I1 plus I2 J80 minus I2 J160. I2 and minus J1. So here we're going to take I1 as common. So I1 is common, which is J40 minus J160 minus J160 I2. V2 is equal to I2 is common, J80 minus J160 minus J160 I1 plus. So this time I'm writing it first. So the standard format of writing the expressions, we have V1 V2 is equal to Z11 Z12 Z21 Z22 multiplied with I1 I2. So what is the equation of V1? V1 is equal to Z11 I1 plus Z12 I2 is one equation. Next equation is V2 is equal to Z21 I1 plus Z22 I2. So here when you perform the simplification, this is like only direct already this is in A plus IB form, so we can perform in the given format. Okay, so here we have 40 minus 60, which is approximately I1 of minus J 120 minus J 160 I2. So here minus J 160 I1 plus I2 into, so this is also a higher number, so minus J80. So when you compare this, the values of Z11 are like this. So this is the value of Z11, this is the value of Z12, and this is the value of Z21, and this is the value of, let's try to put it in a matrix form. So Z11 is equal to minus J120 ohms, Z12 is equal to minus J160 ohms, Z21 is equal to minus J160 ohms, Z22 is equal to minus J80. So already we have been solved a lot of problems of this variant. Let us try to recall where which makes us more simplified. Okay. So how to find out Z11 is already I told you. So this is Z11 is the sum of J40 and J60. You can see here J40 and J60. So the sum of J40 and J60 is Z11. Okay. And next one is Z22. So Z22 is the sum of J60 and J80 and minus J160. So this center, I mean the half diagonal elements are the same, minus J160. This is how to solve a problem professionally without solving by KVL methods or direct expressing in standard format if you have become more expertized. So now let us try to solve it by one more method also, what basically we have. Okay, so I'm going to apply the methodologies. This is method 1. So now this is method 2. Okay, so in this method how to apply is, so now already we have the basic equations of v1 and v2. So from these basic equations, let's try to represent in the standard form. Okay, or you will directly do here where you can understand better. So the basic equations of v1 is equal to z11 I1 plus z12 I2 is one basic equation, and second equation is v2 is equal to z21 I1 plus z22 I2. So here I'm going to solve it by method 2, which is a little bit more simplified if you understood it. So here I'm making input port is open circuited. If input port is open circuited, automatically I1 becomes 0. So I1 is 0 here and I1 is 0 here. When I1 becomes 0, then you are, when I1 is, okay, then doing it, okay, we will find out with respect to output port, which is a general procedure and standard procedure. Output port is open circuited, automatically I2 becomes 0. Now I2 is 0, I2 is 0. Whenever I2 is 0, therefore Z11 is equal to V1 by I1 is 1. So when I2 is 0, okay, so this I2 is 0, then you are going to get Z11 equal to V1 by I1, and Z21 is equal to V2 by I1. Okay, so next, as I already told, input port is open circuited, I1 is 0. Okay, this becomes 0. Therefore, the value of Z12 is equal to V1 by I2 and Z22 is equal to V2 by I2. Now let us try to find the four parameters as it is. Okay, so when you come to this problem, so here first what we are going to perform is the output port is open circuited. So try to draw the same network. So this is the inductance, this is the capacitance, and a current of I1 is flowing excited with a voltage of V1. This is plus J40 and this is minus J160. Here you can see here current becomes 0, I2 current becomes 0. Okay, what is the drop here? Drop is I2 into J80. Since output is open circuited, voltage becomes 0. 0 into 8 is also ohms is also 80. Therefore this complete port becomes as short circuited, V equal to 0. Therefore here we are going to have V2. So as soon as the polarities are same, automatically this will be our V2 and this is the current. Now we require the relation of V1 by I1 and V2 by I1. So now let's try to write down the expression of I1. I1 is equal to, what is the current with respect to V1? What is the voltage at this point? V1. I1 we can write down it as V1 minus 0 divided by J40 minus J160 is one equation, and so from here we require the ratio of V1 by I1. So bring this I1 to the denominator. V1 by I1 is equal to, uh, when you solve it, you're going to get 40 minus 160. Directly can do the subtraction. Why? Because these are in a plus ib form, a rectangular form. This is minus 120j, and I what is the current in this branch is I1. Okay, the current in this branch is I1. Okay, so how to write down the current I1? I1 is equal to V2 minus 0 divided by minus J 160. We require the ratio of V2 by I1. So bring this I1 to the denominator. V2 by I1 is equal to minus j 160 ohms. So successfully we have been solved the first procedure. So Z11 is minus 120j, this is minus j 160 ohms. Now for the same circuit, let's try to make the output port is open circuited. So whatever the method you feel comfortable, you can employ it. So this for left to your convenience. Okay. So here we are going to perform. Now input port is open circuited. When your input port is open circuited, I1 becomes 0. Okay. So when I1 becomes 0, you can see here what is the drop in this branch. This is I1 into J40. Now what is the value of I1? 0. 0 into 1 ohm is once again 0 volts. So I can say that this branch completely acts like an short circuit. What is the voltage at this point? V1. And what is the current in this branch is I1. Okay, it's already 0. So this is the capacitance we have, and this is the inductance. This is V2. This is J80 ohm. This is J160 ohm. So now what is the current in this branch? I2. Okay. So now how we are going to solve this is very important. Okay. So here in this branch we require the two ratios. One is V2 by I2. So as already discussed here, so we require V2 by I2 and V1 by I2. So it's very simple. So while you are solving, you should be very careful what we require, what is there in the problem. Okay, so how to write down I2 now? Okay, so I can write down I2 is equal to, with respect to V2, current I2 flows in this branch like this. Okay, so I2 current flows like this. Okay, I2 is equal to, what is the voltage at this point? V2 minus 0 divided by J80 minus J160. So I can, from this we can write down V2 by I2 is equal to, so 80 minus 160 is minus 80J. Okay. Next one, here the voltage short circuited, here it will be shifted. What is the current in this branch? Which is nothing but I2. I2 is equal to V1 minus 0 divided by minus J160. Okay. So now I require the ratio of V1 by I2. Bring it to the denominator, which is once again minus J minus J160 ohms. Now substitute these values. So here we are going to get V1 by V2 is equal to minus J160 ohms, and this is minus 80J. Okay, this is like subtraction only. You could take J as common, 80 minus 160. 80 minus 160 is minus 80. Now you can verify the answers with each other. So if you check it by both the methods, the answer is same. So here by method 1, answer is J20 minus J20 minus 160, 160, 160 and 80. So you can see here both the methods answer remains same or in a queue. So if you feel comfortable, first method is directly application. You can use KVL method or, and you can directly solve it. Or if you want to solve it of your own, you can use method 1 or you can use method 2. Okay. So this is method 1 of solving by applying KVL. and this is method 2 of solving by using which has to be open circuited and which has to be short circuited, but ultimate answers are same. So the procedure of learning this subject is first write down the given question, first listen lecture and write down the given question and try to solve of your own, then you can feel more comfortable in solving, and if you get the answer, that confidence is entirely different. Okay, that's how to solve it. So already I disclosed how to get the Z11 is sum of these two branches, Z22 is sum of these two branches, the center branch, the shunt branch is nothing but we are going to get it here. Okay, this is the proper procedure of solving this problem. Hope you are able to understand. If you are watching the channel for the first time, if you feel the content is really useful, please like the channel, please share the video, and if you have any doubts, let me know in comment section, and please subscribe to the channel where this is a free channel for the benefits of student and faculty. Thank you for watching. We'll meet in the next video. Yours obediently from